my dear. Welcome to this quiet night together. You are safe here, and you can let go. Let your shoulders soften, your breathing slow, and your mind grow light. Tonight, we won't just fall asleep. We will drift gently across the stars. I'll guide you through the Milky Way, our home galaxy, a spiral river of light, older than time itself. As you listen, let curiosity spark, but let sleep take you too, because tonight, the universe will become your lullaby. Now, let's begin our journey. The Milky Way has already collided with other galaxies, and it will again. Our galaxy may feel like a safe, stable home, but in truth, it is built from the wreckage of others. Over billions of years, the Milky Way has absorbed smaller galaxies. It pulls them in, unravels them, and scatters their stars into thin streams of light that wrap gently around its disk. Even now, one small galaxy, the Sagittarius dwarf, is being pulled apart. Its stars slowly falling into ours, and far away, another spiral, Andromeda, is drifting closer. In about 4.5 billion years, the two galaxies will meet. It will not be violent. The stars are too far apart to collide. Instead, the shapes of both galaxies will stretch, bend, and fold together. Slowly, quietly, they will merge into one. Even galaxies are not eternal. They evolve, they collide, and they begin again. Some stars in the Milky Way are older than the galaxy itself. Not every star we see was born here. High above the galactic plane, in the halo, astronomers have found ancient stars moving in long, tilted orbits. They carry almost no heavy elements. Their light is simple, pure, made mostly of hydrogen and helium. These stars were born shortly after the Big Bang, long before the Milky Way had its shape. They are like quiet elders, drifting through space. Their presence is a memory of a universe still young, wild, and learning how to become what it is today. Our solar system is not still. It orbits the center of the Milky Way at more than 800,000 kilometers per hour. Even at that speed, it takes about 225 million years to make a single loop around the galaxy. Astronomers call this a galactic year. Since the solar system formed, we have circled the Milky Way only about 20 times. When the first dinosaurs appeared on Earth, we were in a very different place in the galaxy. The stars we saw then were not the same stars we see now. Everything is moving, quietly, slowly, endlessly. Even as you rest tonight, the Earth turns, the moon circles, and the entire solar system sweeps forward through a galaxy in motion. The Milky Way is still growing. Although it is ancient, it isn't finished. Even now, our galaxy gathers new material, gas from the empty spaces between galaxies, stars from small captured galaxies, and streams of dark matter all drift inward, feeding its halo. Sometimes this growth is gentle, like quiet clouds settling in. Other times, it is disruptive, as satellite galaxies are torn apart, their stars scattered across the sky. The Milky Way you live in today is not the same galaxy the dinosaurs saw, and the one your distant descendants may know will be larger still, stitched together from the ruins of 1,000 smaller worlds. We don't know how many arms the Milky Way has. It seems like something we should know, but from our position, deep inside the disk, it is difficult to see the whole shape. Thick clouds of dust hide distant regions, and stars blur into one another. For a long time, astronomers believed there were 4 major arms, but newer observations suggest maybe fewer, or perhaps the arms split and twist in ways more complex than expected. Some arms fade into fragments, others wrap around in unexpected curves. The Milky Way may not be a neat pinwheel at all. It may be a living swirl of stars, shaped by forces we still don't fully understand. Most stars drift calmly through the galaxy, but a rare few are thrown out. These are called hypervelocity stars. They travel so fast that they can escape the Milky Way entirely. Some begin as pairs, orbiting together, but when they pass too close to the supermassive black hole at the galaxy's center, their bond is broken. One star falls inward and disappears. The other is slingshotted away, hurled into the dark at more than 1,000,000 kilometers per hour. These rogue stars travel alone, far beyond the galactic plane, like glowing comets with no return. They remind us that even in a galaxy bound by gravity, there can be sudden release, moments of quiet violence that send stars flying into intergalactic night. High above the horizon, you can see Andromeda. To the naked eye, it looks like a faint blur, but it is a spiral galaxy, much like our own. It lies over 2 million light years away, and yet it is moving toward us. In about 4.5 billion years, the Milky Way and Andromeda will collide. It will not be violent in the way we might imagine. Stars are far too spread apart to crash directly. Instead, their gravity will pull at each other. The galaxies will stretch, forming long arcs of stars. Tidal tails will curl outward. In time, their black holes may spiral together. And after billions of years, the two will merge into one larger system. It will be a slow and elegant dance. The future of our home, written across the stars. Most stars in the Milky Way orbit the center in the same direction. But not all. Some move the opposite way in what astronomers call retrograde motion. These stars are often found in the galaxy's outer halo, and many of them did not begin here. Long ago, they were part of small dwarf galaxies. When those galaxies were absorbed, their stars kept their original paths, moving backward against the stream. It is as if the Milky Way carries memories inside its motion. Each star, a quiet story of ancient mergers and cosmic encounters over billions of years. The Milky Way has not grown alone. It has consumed small galaxies, faint companions, drifted close, and slowly they were pulled in by gravity. Piece by piece, their stars were stripped away. Now they shine inside our halo, our disk, or in long, thin streams that wrap across the sky. Astronomers have traced some of these mergers by studying the motion and the chemistry of stars. One especially large event, called the Gaia-Enceladus merger, added many stars to the Milky Way. It may have even reshaped the early structure of our galaxy. The Milky Way is not a pristine spiral. It is a patchwork, stitched together from the quiet remains of many smaller worlds. Every star carries a fingerprint, a pattern of elements that tells the story of its birth. Some stars are rich in heavy metals, like iron and calcium. They formed in crowded regions where generations of stars had already lived and died. Other stars are almost pure hydrogen and helium. They were born long ago when the universe was still young and heavy elements were rare. By studying these fingerprints, astronomers can group stars into families. They can trace which ones were born here and which ones came from other galaxies. In this way, chemistry becomes a kind of time machine, a, 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 way to read the hidden story of the Milky Way's formation. each star a line of ancient poetry written in light across the sky. Thin ribbons of stars can be seen. They stretch in long, delicate arcs. These are stellar streams, remnants of smaller galaxies that wandered too close to the Milky Way and were slowly pulled apart. As they orbit, their stars are scattered by tidal forces, smeared into graceful trails of light. Some streams wrap around the galaxy like ghostly halos. Others dive inward toward the core. They are quiet evidence of past collisions, mergers that shaped the Milky Way over billions of years. Like the rings of a tree, these streams hold memories. The galaxy carries its past in every faint thread of starlight. The Milky Way is not perfectly flat. Its great disk of stars bends gently upward on one side and downward on the other. This subtle warp was invisible for a long time. Only when radio telescopes mapped hydrogen gas did the shape become clear. Astronomers believe the distortion may be caused by satellite galaxies pulling softly on the Milky Way's edges, or by clumps of dark matter hidden beneath the disk like ripples on a vast spinning sheet. The galaxy flexes and bends, never still, always changing. From a distance, the Milky Way might look as if it were dancing slowly through space. With your eyes alone, you can see only a small part of the Milky Way. On a clear, dark night, far from the city, you might see a few thousand stars. It feels like an ocean of light, but it is only a drop. The Milky Way holds over 100 billion stars. Most are hidden. Some lie behind thick curtains of dust. Others are simply too faint or too far away for our vision to reach. That pale streak across the sky, the one we call the Milky Way, is just the innermost whisper of the whole. We live inside a colossal river of starlight, and yet almost all of it remains invisible to us. Stars in the Milky Way do not all move at the same speed. Unlike planets in a solar system, which follow neat paths around their star, the stars of our galaxy flow more freely. Some sweep quickly through the inner regions. Others drift slowly, far out along the edges. This difference in speed creates the spiral arms. They are not solid structures. They are patterns, like slow traffic waves moving through space. As these density waves pass, they compress clouds of gas, and new stars ignite, lighting up the arms in curls of blue and white. Our own sun moves in and out of these patterns over time. The galaxy is not a clock. It is a current, and we are drifting within it. By all logic, the Milky Way should not exist. The stars, the dust, the gas are spinning too fast. They should fly outward, scattered into space, like leaves in a storm. And yet, they remain. The answer is dark matter, a mysterious substance that does not shine, reflect, or emit light. But it has gravity, and there is so much of it that it outweighs all the visible matter many times over. We cannot see it, but without it, the galaxy would fall apart. Dark matter is the invisible scaffolding holding everything in place. At the very center of the Milky Way, there is a black hole, a supermassive black hole called Sagittarius A star. It is more than 4 million times the mass of the Sun, and yet it fits inside a space smaller than the orbit of Mercury. We cannot see it directly, but we can see the stars around it, whipping in tight loops, moved by its invisible pull. Sometimes gas and dust fall inward. They flare with X-rays as they spiral into the darkness. For now, Sagittarius A star is quiet, but long ago it may have burned bright, like a quasar, a beacon glowing at the galaxy's heart, silent now, but always there. The conductor of the Milky Way's endless dance. The center of the Milky Way is not smooth. When astronomers mapped it, they found a strange shape. Not a round ball of stars, but something different. It swells in the middle, narrows at the ends, like a peanut, or an hourglass made of light. This shape formed from the galaxy's central bar, a stripe of stars rotating slowly, pushing upward over billions of years. Gravity sculpts this heart, stars moving in rhythm, layer upon layer, building a structure that is alive and complex. The Milky Way is a spiral, but at its core, it holds a mystery. Not flat, not simple, but intricate. The spiral arms of the Milky Way are not just made of stars. They are woven from places where stars are born. Giant clouds of hydrogen and dust drift through the galaxy, When these clouds pass into the spiral arms, they are compressed, and new stars ignite. These regions are called stellar nurseries. They glow with light, ultraviolet from newborn suns, paints the arms in shades of blue and silver. Each burst of creation traces the curve of the galaxy, a quiet fire marking the path of the spiral. Even our sun was born in a place like this, long ago. Beyond the spiral disk lies a vast halo. It surrounds the entire galaxy like a faint, invisible sphere. Inside this halo are ancient stars, globular clusters, and enormous amounts of dark matter. Its stars move slowly, spread thin, in long, wide arcs. The halo also carries memories of ancient mergers, streams of stars torn from smaller galaxies, left behind like fossils in the dark. Though dim and nearly invisible, the halo may hold most of the Milky Way's mass. It is the galaxy's quiet memory, still shaping what it becomes. Scattered through the halo are globular clusters. They are compact spheres made of hundreds of thousands of stars, bound tightly together. Many of them are more than 12 billion years old, older than the Milky Way itself. Their stars are metal poor. They formed before the universe had time to create heavy elements. These clusters are like time capsules. They hold clues to how the galaxy was built, what it consumed, and what the early cosmos was like. They drift patiently above and below the galactic plane. Golden spheres of light, carrying the memory of the beginning. Long ago, the Milky Way was full of new stars. It was more active, brighter, bursting with creation. But now, the pace has slowed. There is still gas, but much of it is spread thin, or heated, and harder to collapse. The galaxy is not finished, but it is quieter. Astronomers believe star formation peaked billions of years ago. Since then, it has been gently declining. This does not mean an end. It only means we live in a calmer time, a mature spiral, glowing softly in its middle age, still forming stars, but no longer in a hurry. Some stars in the Milky Way are older than the disk itself. Before the flat spiral took shape, the galaxy was just a loose cloud of gas, dark matter, and stars, slowly collapsing inward. In that early time, the first stars were born. They now drift in the thick disk, or high above in the halo. By by studying their light and their motion. Astronomers can look back into an age before spirals, before order. These ancient stars are like elders of the galaxy, silent witnesses to its birth and its long, slow shaping into what we call home. As the sun moves around the Milky Way, it follows a path called a galactic year. One orbit takes about 225 to 250 million Earth years. In that time, continents drift, species rise and fall, and entire epochs pass. The solar system has made fewer than 25 of these journeys in all of its history. The last time we were in this part of the galaxy, the supercontinent Pangaea was just beginning to break apart. A galactic year is the slow heartbeat of cosmic time. Our sun is still young on this scale, a newcomer in a galaxy that has turned many times before. According to Newton's laws, stars farther from the center should move more slowly, but in the Milky Way, they do not. Even the stars far out orbit almost as quickly as those near the core. This was a great mystery. The galaxy seemed to defy the rules of gravity. The answer is dark matter, an invisible mass that surrounds the galaxy in a vast halo. It cannot be seen, but its pull is strong enough to hold the Milky Way together. With dark matter, the galaxy turns like a wheel. Without it, it would fly apart. It is unseen, but always there. All across the Milky Way lie enormous clouds of gas. They are called molecular clouds, made mostly of hydrogen with traces of dust. Some stretch for hundreds of light years, cold and dark. They hide the beginnings of new stars. Inside, gravity slowly gathers the gas. It collapses into clumps that one day ignite and shine. Some clouds are so dense they block visible light completely. On the sky, they appear as black patches, empty of stars. But behind the darkness, new suns are forming. The future is waiting in silence. When massive stars reach the end of their lives, they explode. A supernova, so bright it can outshine an entire galaxy for a brief moment. But these explosions do more than destroy. They create. The shock waves ripple through space. They compress nearby clouds and trigger the birth of new stars. Supernova also scatter heavy elements like iron and gold, forged in their cores and spread across the galaxy. In this way, supernova are storms of renewal. They tear apart, but they also give moments of chaos that keep the Milky Way alive. The Milky Way is full of light we cannot see. Tiny grains of dust float between the stars, made of carbon, silicate, and ice. Invisible light, this dust hides vast regions. It blots out stars and entire nebulae. But behind the darkness, new stars are forming. Infrared telescopes can see through the dust. They reveal nurseries filled with glowing newborn suns. What looks like emptiness is often a cradle. The dust may hide, but it also protects. It helps gas cool and shields fragile beginnings of stellar birth. What seems like darkness is often the start of something bright. Not every cloud of gas becomes a star. All across the Milky Way, astronomers have found massive, cold clouds that remain dark. Some are too diffuse. Others are held together by magnetic fields or stirred by turbulence inside. These starless clouds drift silently through the galaxy. They are rich in hydrogen, but untouched by fusion. One day, they may collapse and ignite, or they may break apart, their gas scattered into new regions. In these quiet clouds, the galaxy seems to hold its breath, waiting for the right moment to spark new light. Stars are not permanent. They are born, they shine, and then they die. But when they die, they give back. A supernova spreads heavy elements. A red giant sheds its outer layers. A planetary nebula drifts outward like a glowing cloud. All of this material returns to the galaxy. It cools, it condenses, and in time, it forms new stars, new planets, and even life. Every atom in your body once belonged to a star, born in fire, scattered into space, and gathered again. The Milky Way is not a static place. It is a great engine of renewal, always making, unmaking, and beginning again. Astronomers call anything heavier than helium a metal. The very first stars had almost none. They were made only of hydrogen and helium. Later generations of stars forged heavier elements in their cores, and when they died, they scattered those elements into space. Today, scientists search for metal-poor stars in the halo of the Milky Way. These stars are among the oldest in existence. They carry the chemistry of a time long gone. By studying them, we can glimpse the universe as it was just after the Big Bang. They are not just stars. They are fossils of light, silent witnesses to the dawn of creation. A star's birthplace does not always decide its path. Over time, many stars drift away from where they were born. Some are pushed by the pull of other stars. Some are nudged by the spiral arms. Others are flung out suddenly at high speeds. Even our sun is not where it began. Stars wander. They migrate inward or outward, like travelers across the galaxy. The Milky Way is not still. It is alive with movement. Every star, a journey of its own. Home is only temporary, just as Earth orbits in a zone not too hot and not too cold for life. The Milky Way may have its own habitable zone. Near the core, radiation is too strong. Gravity is chaotic. Life would struggle there. Far out on the edges, there are fewer heavy elements. Planets may be harder to form, but in between lies a wide band where conditions are calmer. Star density is moderate, and the right ingredients for life are present. Our sun sits inside this band, one quiet orbit in a vast swirl of stars. Here, life found a foothold. And maybe elsewhere in this zone, it has too. The spiral arms of the Milky Way look solid from far away, but they are not fixed structures. They are patterns, waves of density that ripple slowly through the disk. As gas and dust pass through, they are compressed. New stars are born. They light up the arms for a while. Then those stars drift out again. The spiral arms move at a different speed than the stars, like a traffic jam flowing along a highway. From a distance, the Milky Way looks orderly. From within, it is always shifting, never still, always flowing. Beyond the light we see, the Milky Way hums with invisible energy. Cosmic rays, born in supernova and distant galaxies, stream through space. They even pass through your body every second. X-rays and gamma rays shine from dying stars and black holes. Radio waves drift from gas clouds, from pulsars, and from the cold breath of hydrogen. We cannot see these energies with our eyes, but they are there. The galaxy is not silent. It glows. It whispers in many frequencies, a hidden symphony in the dark, above and below the center, stretch two vast shapes of light. They are called the Fermi bubbles. Each one spans tens of thousands of light years. They glow in gamma rays, like ghostly balloons, rising from the galaxy's heart. No one knows for sure what created them. They may be the mark of a long-ago outburst from the central black hole, or perhaps they were born from a fierce storm of star formation. Now, they drift silently, invisible to human eyes, echoes of ancient violence, wrapped in light, lingering above the Milky Way. Our solar system does not lie in a grand spiral arm. Instead, we live in a small lane called the Orion Spur. It rests quietly between two larger arms, Sagittarius and Perseus. The Orion Spur is not especially dense. It is not especially active. But maybe that is why we are here. In this calm corner, supernovae are rare. Radiation storms are less frequent. This quiet place may have given Earth the time it needed for life to grow and to evolve. From the outside, the galaxy looks dramatic. But here, in this gentle spur, we found peace. At the center of the Milky Way lies a glowing bar of stars. It stretches across the core like a shining bridge. This bar rotates slowly, and its pull shapes the inner spiral arms. Bars like this are common in galaxies. They form when stars drift inward and gather along a central line. Over time, the bar becomes stable. It stirs gas. It sparks new stars. And it feeds material toward the black hole at the heart. It is not just a shape. It is an engine, sculpting the galaxy from within. The Milky Way is not alone. It belongs to a family called the Local Group. More than 50 galaxies drift together through space. The two largest are the Milky Way and Andromeda. Around them circle many smaller galaxies. Some are faint dwarfs. Others are dim ellipticals made mostly of dark matter. The local group spans over 10 million light years. Its galaxies are far apart, but bound together by gravity. We are part of this family. Quiet islands of stars, linked by invisible threads, drifting through the dark, side by side. The local group itself is only one piece of something greater. It drifts on the edge of the Virgo supercluster. This vast structure holds thousands of galaxies, spirals, ellipticals, and dwarfs, woven together into threads of light. And even this supercluster is not the end. It is part of a still larger web, a cosmic lattice of filaments and voids that stretches across the universe. The Milky Way is just one spark in this endless network, a single voice in the quiet chorus of the cosmos. The Milky Way is not fixed in place. It drifts through space, pulled by unseen forces. Our galaxy and the entire local group are moving toward a region called the Great Attractor. It lies hundreds of millions of light years away, a concentration of galaxies, clusters, and dark matter, so massive that it bends the paths of others. We cannot see it clearly. Much of it is hidden behind the dust of our own galaxy, but we feel its pull. The Milky Way is falling toward it, along with thousands of other galaxies. Even on the largest scales, gravity shapes the flow, guiding everything toward unseen centers. And now, our journey through the Milky Way comes to rest. We have drifted past stars, past clouds, and past the quiet halo that surrounds us. The galaxy is vast. It is ancient, but it is also alive, always moving, always changing, and you are part of it. Every breath you take, every heartbeat is written into this cosmic story. Tonight, you can let go. You can rest, knowing you are safe. A small but beautiful piece of the Milky Way. Close your eyes. Let your body sink and drift, just like the stars. Good night. Sleep well and dream among the galaxies.